Good morning, students. In today's video, we are going to cover this particular topic, convection current theory of Holmes. ठीक है? Okay, convection, let me change the color. Convection current theory of Holmes. So, in this particular theory, we are going to see that the Arthur Holmes postulated his thermal convection current theory during 1928 to 29 to explain the intricate problems of the origin of major relief features of the Earth's surface. So, what he says that the mountain building happens because of the convection current. So mountain building happened because of the thermal convection current originating from deep within the earth. Thermal convection current. Okay. So this is what leads to the mountain building, according to him. So we have heat inside Earth is formed by radioactive elements. Okay. So we have radioactive elements inside the Earth's surface. Okay. We have these radioactive elements inside the Earth's surface and heat is generated by them. So heat inside Earth is formed by radioactive elements. Heat melts rocks and forms magma. So what happens is the disintegration of these radioactive elements. So the disintegration of radioactive elements generates huge heat, because of which the rock melts and form magma, and thus causes the convection current. This is the main thing. Okay, so radioactive elements they are disintegrate, means they are broken, and this releases huge amount of heat. This heat converts the rocks to magma, and what happens? The hot magma rises, okay, inside the surface, and the when it gets colder because the heat escapes from the crust, so when it gets colder, it again sinks. Okay, so this is what happens. Hot magma rises, and then cold mag means the cool magma sinks now. So mechanism. Let's study about the. This is the base of the theory also. So base of the theory is basically the radioactive elements. Radioactive elements. Okay. That causes the heat. These radioactive elements disintegrate, broken, and which releases the heat. Heat converts the rocks into magma, and that magma causes the convection current. And this leads to the formation of the mountains. How? Not by the convection current, that we will see further. So, what is the mechanism of the theory? So, basically, um, just a second. Yes. So, according to Holmes, uh, he divided the convective currents into two major groups on the basis of their location. So, the convective currents of the rising columns and the convective currents of the falling columns. Okay, so he divided the convective currents into two major groups based on their location. So, according to Holmes, The equatorial crust was stretched and ruptured due to divergence of rising uh, convective currents which carried the ruptured crustal block towards the north and south, and syncline was created as the sea between two blocks. So what happens is near the equator, the this convective currents, this rising convective currents separates the crust, and what happens is this these rising convective currents, this is the crust, so it divided the crust, okay, and the crust is divided, and one goes in the north direction, one in south, and are tits basically tits C is formed between these, okay, between these. So this is what happens. So this is called as the opening of tits, okay. Again, two sets of convergent and downward moving currents pull Lower Asia and Gondwana land toward each other, and thus teeth was compressed and folded into alpine mountain. So what happens? So again, these two sets of convergent or downward moving current. So now this is the because of the rising convective currents, the crust is broken into two parts. Okay, and the teeth C was formed. But when this convective currents goes downward, it leads to the closing of these, means coming together of these two lands. One is the Laurasia and the other is Gondwana, according to Holmes. And these and the pits that is existing between these two plates was compressed and folded into alpine mountains. So basically, this sea is a syncline. Okay, it's a syncline. That means we know that what does the syncline mean? It's a depression, and in that depression there are a lot of sediments. So basically, the closing means the downward movement of convective currents leading to the closing of this Laurasia and Gondwana land, and the pits, the syncline between them form the mountains. Okay. So according to Holmes, the cyclic pattern of convective current and related mountain building pass through three phases or stages. Now let's walk through them. So this, I hope this is clear. Let me again summarize this for you. Basically, two main thing happens here: opening of pits and the closing of pits. And what is pits? Pits is a syncline, a depression composed of sediments. So when the convective currents rises, it leads to the broken of the crust into two parts. Those parts are these, like one part is in the north and the one is in the south, and at its form between them the syncline, which is of course the syncline. When the convective currents move downwards, it leads to the closing of these two lands or parts which are separated, you know, and when they come together, the pits that is present between them, it converges and form the mountains. That's it. So now let's talk about the three phases or stages that Holmes highlight: lithogenesis, orogenesis, and the third stage is glyptogenesis. Okay, so lithogenesis. So basically, in the first stage, what happens is the geosync formed. Let me write down with other pen. So what happens in the first stage? Geosynclines form. Geosynclines, as we know how they form. Okay. Uh, so these formed, and the sediments present in the geosynclines, it moves downwards and metamorphs. Metamorphs. Okay. Metamorphs. What does that mean? That means change in form due to the heat and pressure, etc. So change in the form of the rock, etc. Uh, because of experiencing a lot of heat and pressure. So the geosynclines that are formed, okay, by the by like these rising convective currents of two centers converge under the continental slabs and thus form geosynclines due to the compression coming from the convergence of two sets of lateral currents. So these currents form the geosynclines. Geosynclines are formed from these currents, convective currents. So in the lithogenesis, what happens is these currents are formed, and because of these currents, geosynclines are formed. Geosynclines have sediments in them, so sediments move downwards as the sediments started to accumulate in the geosyncline. Because of that, the weight increases and the crust move down, and the sediments along with it go downwards, and under the earth's surface they metamorphs. Because under the earth's surface there's a lot of heat and pressure, because of which it metamorphs. In the next orogenesis process, the convective currents, I am writing CC, convective currents buckle geosyncline sediments and form mountain. So the convective currents buckle the geosyncline sediments. Buckle means, what does buckle means? Means bend. Buckle means bend or fold. So the convective currents buckle the geosyncline means bend or fold the geosynclines sediments and form the mountains. Okay. And in the glyptogenesis, here the termination of mechanism of convective currents yields means the currents terminate, that means stop, and because of which in glyptogenesis convective currents stop, and because of which several results or several things happens. The first is the material of the falling column start rising because of decrease in the pressure at the top of the falling column due to end of deposition of materials. This mechanism causes further rise in the mountains. So what happens is the falling columns, that means the convective currents that are falling at the top of their surface, the pressure decreases. because of the end of deposition of materials. So, because of that, the crust rises and cause more elevation of mountains. This thing happened, and the second is the metamorphosed rock agglomerate with increased density being heavier, depressed downwards, and gets melted due to immense heat, and thus it expands. So the metamorphosed rocks with increased density, they became very heavier and they goes downward into the, you know, they into inside the earth's surface. There they, because of intense heat, they melted and expands. So we have talked about here the metamorphosed rocks. What happens with them? What happens with the metamorphosed rock? They, because they have in high density, they depress downward and there they melted and there they expand. So the expansion in the volume of molten agglomerate causes further rise in the mountains. So it, because of this, rise in the mountain happens. So because the heavier means it expands, so the crust again becomes lighter and again the crust rises. So this is called the glyptogenesis. So glyptogenesis, in that the convective currents stop. In lithogenesis, we see that the geosynclines form, sediments form, downward thing happen, metamorphs of the rock happen, and these convective currents, they are continuously moving. They are buckling, that means bending or folding the sediments present in the geosynclines that lead to the formation of mountains. And in the glyptogenesis, those convective currents stops. And the termination of those convective currents also lead to the rise in the height of the mountains. This is the whole thing. So I hope this topic is clear. If you have any doubts, feel free to ask in the comments. That's it for this video. Thanks for watching.